We put a ton of trust in our technology, right? But what happens when the world outside is waging this kind of hidden war against the machines we rely on inside our own homes?
I mean, we've all been there. The air conditioner just quits on the absolute hottest day of the year. Or the furnace gives up the ghost in the middle of a brutal cold snap, and we just figure, a part must have worn out. But what if the real culprit isn't a faulty wire, but the very air outside your window?
That's right. Your location, the very environment your machines have to live and breathe in, can be this invisible force that pushes them right to their breaking point. And to really see how this works, we're going to go to a place where this battle is fought every single day.
Okay, let's head to Glendale, Colorado. It's a city where technology is under this constant assault from nothing more than its own location on the map. And the whole story really starts with one single, staggering number.
5,331 feet. That's Glendale's elevation. We're talking nearly a mile above sea level. Now, for the complex machines in our homes, trying to operate that high up, well, it's like asking a marathon runner to compete with way less oxygen. Yeah, they can do it, but the strain is just immense. See, it all comes down to a fundamental difference in the atmosphere. At sea level, the air is thick, it's dense, it's just perfect for things like heat exchange and combustion. But you get up to high altitude, and that air is thin. It carries less oxygen, and there's just less substance to it to pull heat away from all those hard-working parts. And the scale of this problem is huge. We're talking a 17% drop in air density in Glendale compared to the coast. Now, this isn't some tiny little difference. It fundamentally changes the rules of the game for any machine that relies on airflow. But believe it or not, thin air is only half the story.
The other enemy here is something called thermal stress. In a place like Glendale, it's totally normal for the temperature to swing 40 degrees in a single day. Every single time that happens, the metal components inside your furnace and your AC are expanding and then contracting, just getting a little bit weaker with every single cycle. It's like this slow motion attack that eventually leads to catastrophic failure.
So what does this relentless one-two punch of thin air and thermal stress actually do to these machines? Let's take a look at a couple of the most common ways these forces cause systems to just completely give out. So first up is something that sounds completely impossible, a real paradox of physics. Your air conditioner freezing itself into a solid block of ice in the middle of summer. I know, it sounds crazy, but at high altitude, it's a constant threat. Here's how it happens. That thin, low-density air, it just can't pull enough heat away from the system's evaporator coil, so the coil gets colder and colder and colder until the condensation on it literally freezes into a block of ice. That ice then chokes off the refrigerant flow, and just like that, your cooling is gone. Kaput. All right, the second common failure is even more serious. We're talking about the heat exchanger. This thing is basically the heart of your furnace, and thanks to that relentless thermal stress we just talked about, it can develop really dangerous cracks. Think about it. Day after day, that 40-degree temperature swing is flexing the metal back and forth. A tiny, microscopic fracture appears. Then it grows. And this is the scary part. A cracked heat exchanger isn't just a breakdown, it is a critical safety hazard. It can leak deadly, odorless carbon monoxide gas right into your home. Now, facing all these challenges might seem a little hopeless, but it's not. It just requires a totally different playbook, a science of survival built specifically for these high-altitude environments. This quote from a local pro just says it all. You can't use a sea-level playbook in a high-altitude world. The solutions have to be tailored to the unique problems of the location. Standard procedure? It just doesn't apply up here. A key tool for this is something called the manual J load calculation. It's basically the formula technicians use to figure out exactly how powerful your system needs to be. But here's the catch. If you don't apply specific altitude correction factors to that formula, the calculation is completely wrong. And that leads to systems that are either overworked or constantly shutting themselves on and off until they die. And the difference is just, well, it's stark. A furnace that's rated for 80,000 BTUs of heating power down at sea level, in Glendale's thin air, it's only going to produce about 66,000 BTUs. Now, if an installer ignores that simple fact, they are setting that system up for failure from the moment they turn it on. So, surviving at altitude means you've got to check every single one of these boxes. It means using those adjusted calculations, following different rules for charging refrigerant, understanding that fire itself, combustion, works differently with less oxygen, and of course following all the strict local codes designed for these very conditions. So, why does a whole story about HVAC systems in some city in Colorado matter to you wherever you are? Well, because the core idea here is absolutely universal. This story from Glendale, it's not really just about furnaces and air conditioners. It's a perfect case study that pulls back the curtain on a much bigger truth about the relationship between our machines and the world they live in.
Whether it's the corrosive salt air on the coast that's eating away at your car, or the superfine desert dust that's clogging up your computer's fans, or even extreme humidity shorting out your electronics. All of our technology is fighting this invisible war against its surroundings all the time.
So the next time one of your devices fails, maybe look beyond the machine itself for a second. Ask yourself, what unseen environmental pressures are at play here? The answer might just be hiding in plain sight, right there on the map.